Today's topic is set theory. First of all, we will talk about set. The definition of set is it is the collection of well-defined and different objects. So we will be having some objects or elements, and the collection of those objects which are well defined and different, that collection will be called as a set. Fine. And from the word well defined, we mean suppose we are having any set. Let just name this set as A, and it is the collection of A, E, I, O, U. This is the collection of elements. The collection of these elements is well defined. Why well defined? We have a definition that these elements will be vowels in English language, right? And all these objects are different, so that is also one of the reason, like we are saying that this is a set. In case we have a collection of sets in which the function or the relation in between these elements is not defined, then we cannot say it to be a set. Okay. Or there will not be any different objects, then also we cannot say that this is a set. Fine. Just let us take an example which is not a set. It is a collection of intelligent students of grade 10. Fine. This is not a set. Why? Because this is not a set because the definition of intelligence is not defined. Who are intelligent? Above 90% are intelligent, above 80% are intelligent, above 70% or 60%. So that thing is not defined over here in this set. So the term which is required for a collection to be a set which is well defined, it is not applicable here. Fine. So yes, there could be different students if the second condition is satisfied, but the first condition, well defined elements, is not applicable over there. Apart from this, rather than intelligent students, if we take the collection of students of grade 10, simply the grade 10 students, then yes, it is a set. Why? Because the collection of elements is different, all students will be different, and all elements are well defined. What is the definition of the students? These are students of grade 10. So in this way, this will be a set. Fine. And if any element, let A is the element which belongs to set A, or we can name any alphabet like A, B, C, X, Y, Z. So capital letters can be represented for a set, and the objects which belong to the set, or the elements which belong to the set, will be represented with the small letters like A, B, C, X, Y, Z. So if any element belong to a particular set, let A belongs to the set A, we will say that A belongs to capital A. Fine. In case A does not belong to A, then we will cross it like this. This element does not belong to set A. Fine. Now representation of a set. How to represent a set? In representation of a set, there are two ways to represent any set. The first form is called as roster or tabulation form. In this form, we simply list all the elements in a set. For example, if A is a set and it is the collection of vowels from English language, then we will say that this is the roster form of a set, or we are representing our set with the help of a roster form or a tabulation form. Fine. Or we can say that we can take another set I. This is the collection of or I would say that just take n just for simplification. So this is the collection of all the natural numbers, so it will start from 1 2 3 4 and so on. So we are listing elements in a set. Fine. So this is the roster form or the tabulation form. Second is set builder form. In set builder form, what we do is in set builder form, we simply write the general element, if I want to represent this a general element x, so this set will be the collection of all the elements x such that x is a vowel in English language, right? So in this way, I am representing the same set here in a roster form, here in a set builder form, and we will collect all the elements in both the forms with curly bracket. Keep this in mind. And the second set I can represent, this is a collection of all the elements x such that x is a natural number. Fine. So this is all about how to represent a set. We can represent in both the ways. Okay, so we will talk about finite set and infinite set. What is a finite set? Finite set is the set in which the number of elements in the set is finite, means we can count those elements, and that set will be called as a finite set. For example, this set A is a finite set. Fine. In the same way, as the name represents, infinite set is the set in which the number of elements are infinite. That means we cannot count the number of elements in that set, so that set will be called as an infinite set. And the second set, here we can say that this the set of all the natural numbers, we do not know what is the value of the last natural number, so this is an infinite set. Fine. And we have another set which is singleton set. So singleton set means any set. Singleton set means any set which has only single element. So we can have some sets, say B, and the number of elements is only one. It is only x, it is only y, only z. So in this way, I want to take an example. Let A is an element. This is the collection of all the elements x such that x is a square root in between 30. X is a perfect square, not a square root. X is a perfect square in between 30 and 40. So we will start from 30 to 40. We will see which is the perfect square. 31 is not a perfect square. 32 no. 33 no. 34 no. 35 no. 36 is a perfect square. 36 is a perfect square. It is the square of 6. And 37, no, 38, 39, 40. So we are having only 36 in between 30 and 40, which satisfies the condition that that should be a perfect square in between 30 and 40. So set A is a singleton set, right? So this is all about finite set, infinite set, representation of a set, and how which collection can be called as a set. There could be many collections, as I have told you, many collections, but all those collections cannot be called as sets. Fine. Is an empty set or a null set or a void set, as the name represents. So any set which contains no element is called a null set, or any element which is having zero element, and those elements are always represented with this symbol, and this is called as phi. This will be pronounced as phi. Fine. So this is an empty set. So we have talked about finite sets, infinite sets, singleton set, empty set. To give example of an empty set, a set A, this is the collection of all the elements x such that x is a positive integer which satisfies x square is equal to 1 by 4. So if we fill x with any positive integer, and the answer should be 1 by 4, and as we know that if we fill x is equal to 1 by 2, then only plus minus 1 by 2, then only we can get this answer, and 1 by 2 is not an integer. This is a rational number. So in this case we cannot find any integer which can give us this value on squaring it. So this is a phi set, empty set, null set. Okay, or I can take another example. Let us take set B. This is the collection of all the elements x such that x is a fraction which satisfies x square is equal to 9. So again we know that only 3 square plus minus 3 square can give us 9 on squaring it. So any fraction, we cannot have any fraction which can give us this answer. So in this case also the set will be empty set, null set, void set. Fine. So this is all about sets. I have given you some basic knowledge about sets, and in my next video we will further go deep into this topic, and thank you so much for watching.